application, tanks. This is going to be about time savings and cost savings when it comes to solutions that you're looking for on your tanks. We got to admit somebody in here. All right. So again, like I said, thank you for your time. We're going to be looking at tank repair, maintenance, and protection. Very vital asset of your operation. Basically, a lot of these can be done in situ as well as with bare minimum time, so you can get these back in service as quick as possible. We're going to have Alex, our in-house engineer. He will be conducting this webinar. Wealth of knowledge when it comes to tank maintenance, and we can comfortably say when it comes to tank repairs, protection, and improvement, this is something that is definitely in our wheelhouse, in our bread and butter, as they say. So I'm going to go ahead and pass this off to Alex. I do want to say in the comment section, if you could please give me an email address, a name, or a phone number. I need either of the three. I need name and email for sure to get you your professional credit hour for 1 hour for attending. We'll get those sent out to you right away. All right, Alex.
All right, thanks, Quinn. Thanks, everybody, for joining in today. Like Quinn mentioned, this is our once-a-month webinar. Like to keep it interesting, keep it relevant. This week, we're going to do in-service repairs and modifications for tanks. The big benefit being that they're going to be in service, no need to shut down, no need for hot work. Comes in handy in a lot of situations where you can't do any welding and you can't afford to shut down or empty out a tank and do a repair. So as you can see on this slide, a lot of different things. We're going to cover them all. Tank base sealing, external coatings, composite repairs, metallic plate bonding. So we'll start from the bottom. Tank base sealing. This is one of our solutions that's used across the board, across the world, really, in a lot of specifications. It can be done while the tank's in service. The big thing being here is that you are sealing off the tank chime area and not allowing any ingress of water underneath your tank, any corrosion at the tank base. It's very easy to install. One of the great things about it too is once you install it, it's a breathable system. So it allows any trapped water to escape as it vaporizes into, evaporates, but doesn't allow liquid water to go underneath. So in terms, it's a pretty simple product, and it's a very simple application as well. There's no need for any special tools. You can learn how to do this in one afternoon. Come by the shop and we can show you. It's a one component product. It comes in a 5-gallon bucket. You prep your surface. The preparation is minimal. You can go anything from, a light abrasive blast to just removing any loose paint or loose rust. Just depends on what you can do at your tank. And then it's just a quick application. As you can see here, there's 2-coat system. You apply a primer, a first coat, and a second coat, and allow it to cure. Now, beyond tank base sealing, it's used in a lot of different scenarios, such as tank roofs. So this is a geodome where it had some leaking at the seams and water was getting into the tank and contaminating the tank contents. So they used it in this case to stop water from getting inside the tank. And on this bolted roof, it was the same problem. They were having some issues with water ingress into the tank from rain. So in this case, we did do some initial sealing with one of our elastomers in some of the bad leak areas. And then we sealed all the bolts and all the seams with the same product, Belzona 3111. So going up the tank and onto the shell, CUI repair and protection. These are some pictures of some CUI. Typical CUI, we see, water settling on top of a manway, water settling on top of support rings or stiffener rings and causing some localized corrosion areas. Now, when it comes to protecting the externals from CUI, if you're out of service, we have a lot of coatings, and epoxy coatings can be used. They can be applied. Most epoxies and some of ours can be applied anywhere from 140F down, and they don't have any issues. So you can obviously apply an epoxy coating when you're down, and it can operate and it can work while it's in operation. Now, the tough part is if you have an insulated tank, for the most part, it's going to be a hot tank. That's why you're insulating it. And you can't really apply most epoxies at elevated temperatures, anywhere from 150 to 300 is what I'm putting here. However, we have some epoxies, which we call our heat activated products, which are designed to be applied at these temperatures. So once they see the substrate temperature of anywhere from 150 to 302, they activate and they start to cure. So these come very handy when you're doing an in-service repair on a repair. So you're doing your monthly inspection, you suspect that you have some CUI, you remove some of the insulation, you find you do have some CUI, you can remove some of your insulation, get to where you have some good metal, and then you can go in, remove any loose rust scale and apply these products. That's another great thing about these. They don't require any heavy blasting or extensive surface preparation. All they require is an SP2 surface preparation, which is a hand tool prep, remove any loose rust, loose paint scale, and apply the product. So this is an in-service repair that we do quite a bit. You can see here, they had a localized pit. It was covered up and coated. And here the same thing as well. And we've seen these last till the next shutdown. They really preserve your metal and stop that CUI, which can cause a major shutdown and leak in a lot of scenarios. So going further, we're going to go into the metallic plate bonding. This is one that really has a lot of different options. So if you're not familiar with it, what we do here, it's an alternative to a lap welded patch or welded in equipment. You can use it to install new equipment. You can use it to seal a leak like you see in this picture on the right-hand side. These were all leaks that were sealed with a plate bond. You can use it to reinforce a thin wall area. And they can also be used to carry loads. So I'll go into that a little bit later. But what are the great things? No hot work. So there's a lot of different surface preparation techniques that can get you a great surface profile, get you that great adhesion that you need without a hot work permit. So no hot work permit required. So that's the big advantage there. No need to weld. You can work on tanks with oil, tanks with different contents where hot work is not allowable. So how do we design these systems? We have a lot of different testing. We actually have a newer product, Belzona 7311, which is solely designed for plate bonding. So it has even more testing than our normal products. So anything from adhesion in different directions. So we'll have a cleavage adhesion, a shear adhesion, a tensile adhesion. We have mechanical properties, tensile properties, shear properties. And we use all these to create a bonding system that can handle any loading, any pressure, anything that's going to come into the application when it's in operation. So going further on this, so let's say we have an application. This is one we're working on at the moment, and we've done this several times. We have a client that wants to install. He cannot weld, so he wants to bond in, the tank's in operation. But they want to redo some of the insulation, put some new support rings. So we're bonding in this bracket here, which is going to hold up some weight. The bracket is the bracket that's going to be bonded has a plate that's 6 inches in diameter. So we know that the area of the plate is going to be 36 inches. There's going to be a shear load from the weight. We know Belzona's 7311 shear adhesion is 3,600 PSI. So the adhesion shear loading carrying capacity is 129,600 pounds force. So we know that the weight of the equipment is less than 100 pounds. It's not going to fail adhesively. That's the first thing. Is it going to come off? Is the force too great for the adhesion? We know that's not the case. And 129,000 pounds, that's a lot. So we know that that's not. But can the material actually handle 129,000 pound force? So that's when we use our FEA to determine the mechanical property limits. And it was somewhere around 2,500 pound force that it was able to handle safely. So we can do this and calculate exactly how many plates we need, how big the plate has to be to carry whatever it has to carry. So going into some examples, this is one example where they had some new safety regulations installed into this plant. So because of the safety regulations, they had to install a fire sprinkler system on top of this tank. Now they could not do any hot work, tank was full and they were trying to install these. So this was a perfect opportunity to use Belzona to install these brackets here, which were then used to support all the piping. So in this case, these brackets would be mostly, or the Belzona material would be mostly in compression, which they're fairly strong, stronger than concrete. Not a very hard application for Belzona here. Also fairly quick. I mean, it's not a lot of material. It's not complicated. You don't have to go to school for this. It's you can do this training in a couple of days and really get a good grasp of how to do it. And you can also have a technical Belzona consultant on site to work them through it. It's not a very complicated or doesn't need a lot of specialty tools either. So this is what I was talking about before. We've done quite a bit is install brackets on the side of tanks to hold up equipment. So as you can see here, they're doing what we call a vapor blasting technique, which is blasting with a constant stream of water. With this, there's no sparks. You do not need to fill out a hot work permit for this type of preparation. And it gives you a great profile and allows you to have the optimum adhesion for your brackets. And really, you want the greatest adhesion possible. And then reinforcing areas with metal loss. So a lot of times you might, and this is a CUI scenario, they were having some thinning at the nozzle. Once again, this tank is in service. They can't cut this out and put a new one on. So to get them to their next turnaround, they use this system to reinforce the nozzle. They created a doubler plate that fit the geometry of the nozzle and bonded it in, and they also coated it with our heat activated products. It was actually bonded in with our heat activated products as well. And that way we reinforced the nozzle and also gave it corrosion protection. So moving from the metallic plates to the composite repairs. So we're going fully non-metallic here. We have a lot of different options when it comes to composite repairs. We can go from an ASME compliant engineered repair, which you're looking at here is our Belzona Super App 2. But we also have a lot of different options as far as we have different reinforcements such as fiberglass, polyester, which we can combine with any one of our products. And why would we do that? Well, sometimes you might need something that has a certain chemical resistance. Sometimes you need, you don't have much time. You need this repair to be done and, really quickly. So we have our fast cure products. It might be an oily, or there might be water on the substrate leaking. So we need surface tolerant products. So there's several different things, but we can pick the right product and choose which one would fit this scenario. We also have a line of flexible composites if you have a substrate that's like a floating rooftop tank that has a lot of movement. So going in, we'll start with the ASME engineered composite first. And one of the great things about this repair is it goes by standard. So ASME Article 401, it can be fully designed for the system. And it has a lot of pre-qualification testing, a lot of testing that allows you to engineer how thick and how long each repair has to be. Another great thing, it's also an approved repair as per API 653. So going into it, this is a tank that we repaired while it was in service. They did some UTs from the outside and found that they had some localized areas of internal corrosion. They had a turnaround coming in about 2 years. So they wanted some safety factor here to not have any, shutdown or any leakage, possible leakage. So we did some repairs. Now, the thing about the composites is you always want to extend beyond the defective area. So this might be a localized corrosion area within the repair, and we're just extending beyond it onto better metal. And what this did is it allowed them to get to their turnaround. When the turnaround came about, they coated the inside to stop the corrosion from the inside as well. So we are reinforcing the tank wall. And then once they stop the corrosion source, then they've totally fixed the issue. But in the meantime, we've taking them to their next turnaround. When they get to the next turnaround, they won't have to do any lap weld patches or anything. This has fixed their shell as far as structural integrity. This is a leakage scenario around a manway. This one was a crucial application. It was a methanol tank, and they could not afford to have this leaking any more than what it was. So we designed a repair system that consisted of first a leak seal. So there were several points of leakage, possible leakage, because this was there used to be a manway where this was, and they had some issues where the studs were. So there was possible leakage in all these areas, and one of them was actually leaking. So we sealed off any potential leakage, and then we installed our design composite. So that every step here, as you can see on the right, was planned out. They did not want to have any sort of, a lot of times people are worried about repairing a leaking surface like this and making a worse leak. So we really took that into consideration and designed a system that would prevent that. And it was executed as per the design and procedure. All these people here were trained at our facilities. We train them with every ASME compliant repair. You have to be certified to install it. So we run training programs that go for a day, and they understand the system and are certified to install it. This was an interesting one as well. This tank, they could not take it out of service. They could not isolate it. It was a crucial part of their process, and they had this leak, and they were continuously collecting the leak, and this was sulfuric acid. They were continuously collecting it and then putting it back in. So we came up with a plan where they could lower the tank level just enough to give us enough time to install a repair. So we designed a repair that would cure as fast as possible, but also contain the sulfuric acid. So this first step here, this is before any prep. This is just to seal off the area with our quickest curing product. This product is fully cured in 2 hours, and that's going to allow everything else around it to cure properly. So once we put that down, we did a better surface preparation. We installed a plate bond with a material that's compatible with sulfuric acid at those high, this was 98% sulfuric acid. And then on top of that, we did our compliant super wrap because it needed to be a fully compliant system in this plant. So it worked well. It still went by a couple years later. It was still there and really solved their issue. They didn't have to shut it down. All they had to do was lower the tank for just enough time for this repair to cure. And then another one with the ASME composites. This was a tank that, they had a huge tank farm actually. And then once they put it in operation, they realized they had a bunch of threaded connections that needed to be seal welded. And obviously in this situation could not do any welding. So we found some similarities with the seal welding standard and the ASME composite standard, a lot of similar terms and sentences. And we presented that to the client, and it was accepted. And basically the main thing is the seal welding is used to create a seal. It's not used for any structural integrity. And the Belzona super wrap, according to the ASME standard, can be used to seal leaks, but it also adds structural reinforcement as well. So it kind of does a little more. So it was comparable and equivalent and accepted, and it was installed in over 100 different locations and really saved them from having to do a major shutdown of the whole tank farm, really. So that was a huge win for them and for us as well. It was a good project that went about. And then so now we're moving into, that was the ASME composite. Now we're moving into using some of our different composites. So in this scenario, we're attacking a live leak. You're going to have a contaminated surface. You're going to need products that cure fast, because whenever you're dealing with a leak, it has to set up fast enough to where the leak doesn't stop it from setting up. So here we used a combination of all of our products, our fast cure products, our surface tolerant products. So the first thing we did was we sealed the leak. So this was on a riveted tank. This would be a similar application for a bolted tank as well. we would seal the leak first with one of our quick curing paste grade epoxies. Once we did that, we would go over the top of that with one of our surface tolerant epoxies and combine that with our fiberglass mesh. And this is what it came out to look like for a lot of them. So, I mean, the rivets and the bolts, they do come out a little bit bulky because you do have to pack over those bolts at times. So that's why you see this lump here, just covering up the bolts. But this was done across 4 or 5 of their tanks, and each tank had about 6 to 10 locations where it was leaking, and they would attack about one location a day. And then finally, we do a similar application on floating rooftop tanks that we see a lot. We see a lot of leaks on the floating rooftop tanks, whether it's at the welds or sometimes it's in the middle of the roof plates. You know, we do have a similar procedure where we stop the leak first and then go over the top with one of our composites. So that's pretty much and as you can see, the surrounding tank is, you know, there's some leakage around. This is an area where you cannot do any welding. You can't do any hot work. So we have the solutions where you can go in and stop this leak and apply a composite that's going to give you enough time to get to your next turnaround and really shut down the tank and maybe do some other types of repairs to really get it going. But we've been able to stop them while the tank's in service. And really, that's the big benefit there. So that's about all I had. Once again, thanks for joining in. If you're interested in this and you want to go deeper dive, obviously we can talk about this. It's a very short presentation. We can line up a presentation for you. If you have any questions now, we can.
You got one, Alex? So quick question, Alex. Let's say you apply some of this cold bonding on something and you cold bonded it to the actual tank. What is the data for how it keeps its strength? And when should they come out to check these cold bonded attachment points? Do they do this with some kind of strength test? And what's the years? Let's say like 10 years down the road.
Yeah, I mean, we have a lot of adhesion testing. So that's going to give you your main focal point of how much, you know, it can handle. As far as inspection, I mean, it would be a visual inspection. Every time you go out to do your normal inspection, I'll just take a look at it. Normally these materials, if they're going to fail, it's going to be, you know, off the bat. If something went wrong off the bat, whether it wasn't a good surface prep or it wasn't a good application. But once it's in service and it's working, there's not a lot unless there's a total something that happens out of the blue. I mean, if it's working, it's going to keep working.
Does the new testing, Alex, in the 7311, the cyclic testing, that's also based on years of service, right?
Yeah, so they've done some cyclical testing with the 7311, and that's really our answer to that question as well, because we've been getting that for quite a while. So they designed this system that does a little bit better with, and we can, if anyone's interested in that, the PSS spec sheet on this one has the actual graph of they did 1 million cycles and showed the adhesion and the tensile strength over that 1 million cycles and how it changed over those cycles. So that would be if there's a lot of cyclical loading on that equipment, then I would go with the 7311. But if it's just a static load over a long period, I don't see an issue with any one of our products.
Got any other questions out there?
Alex, I did ask about 7311 on vertical surfaces. We did answer that we usually hold them in place with magnets. No issues on vertical surfaces.
Yeah, you just got to find a way to hold it in place while it cures. And it has a chart on it. I like this product. It has a good chart on exactly how much time it takes to hold the weight that you want. So it's good.
All right.
Barry Burton has a question, looks like.
Well, I don't know that your question, Brian, is, you know, we got an email first of the year about our new training policy. And I think we mentioned training a couple of times in this, so maybe a good review of what our new policy is for folks coming into Alvin to do training.
So the new policy is we were charging just a flat fee for training. What we've decided to do is do complimentary training. Whatever product you're buying for the project, just use some of that product for the training, and that's the cost. We can do it per head if it's simpler, but whatever product you buy, we'll do the training at no charge at our Alvin office.
Any other questions, comments?
Jeffrey, were you trying to ask a question? I saw it light up.
No, sir.
Okay.
No.
All right, guys, if you haven't gotten a chance in that comment section, shoot me your email and a name. When we get these professional development hours out to you, it's a 1 credit for 1 hour. Looks like mostly everybody on here did respond to that. So I